Last lecture of the semester, talking about Chapter 20, Management, Monitoring, and Optimization. So, we're going to start off talking about network documentation, why it's important, what it is, how we do it. Talk about network monitoring a little bit. We're going through that some this semester, and we'll wrap up with network optimization. So, why do we document things? Well, there's a lot of reasons. I think the most basic reason is, you have one employee in a company. Are they likely to stay at your company for an indefinite period of time? Okay, there's turnover, is there not? Let's say you have an employee and they want to take a vacation. Okay, do you want to get a phone call on your vacation, asking a question? Who says they do? Who says they don't? Why not? Taking work on your vacation, that's no fun. So you document stuff, it's less likely to have that happen. Okay? Because someone can go in, read your documentation, and then they can resolve whatever issue they face without having to worry too much about any of the any issues associated with it. Okay, legal reasons. So, let's say you're an internet service provider. There's certain information you're required to document. Yes. Okay. I don't know all the details on that. Obviously, you'd want to be reading up on whatever industry you end up in. Okay. And obviously, you'd want to make sure that you're fulfilling whatever legal and regulatory compliance you may have to deal with. Insurance. Okay. Say your building has a flood. Happens all the time. Okay, so a building's flooded, and you don't have any documentation that tells what equipment you have. You want to go into a flooded building and wade through the waters to get a list of everything? Who wants to do that? Who doesn't want to do that? Why don't you want to do it? Why not? Why it's not fun? Okay. So if you have documentation on what equipment you have, you're not going to be having to wade through that water, are you? You're less likely to, at least. You may still have to, and that's kind of up to your employer, I guess. Troubleshooting. So, say you have a remote site, okay? Do you want to have to physically visit the remote site? Okay, if you know what's at the remote site, is it possible that you could do some additional troubleshooting remotely? Is that possible? Okay, is it a guarantee? Of course not. But it reduces the chances that you'll have to visit the remote site. Okay? You got a remote site, you may have to hop on a plane. Okay, that plane may cost thousands of dollars at short notice. Okay, now obviously you, the employee, wouldn't be paying that, but on top of that, you're spending time away from your family. Okay, that's generally not a fun thing, unless you don't like your family, I guess. But I'm not touching that one with a 10-foot pole. Okay, and then lastly, having a good idea of where your spare equipment is could be useful. So in general, I suggest that when you have a server rack, especially for networking equipment that's relatively inexpensive per unit. Okay, $2,500 is not that much per unit, is it? Okay, relative to the amount that the equipment would allow you to do in business, is it a lot of money? So why not double up? Have spare equipment. Okay. And don't just have spare equipment, but have spare equipment throughout your organization. Okay. Now, I'm not suggesting you buy 2 PCs for every one that you need. That would be silly, would it not? Okay. Talking about your core networking equipment. Probably not even your servers, to be honest, because with servers, you get away with virtualization and stuff like that if you had to. But especially networking equipment, double up on it. All right, so how do we actually document? Well, at the basic level, we need to know what we have and where it is. That's all about schematics and diagrams. So, wiring diagrams and schematics, that's not going to be that relevant to most things, okay? If we were doing something like a PBX, which we shouldn't really do in anywhere past 2018, because the regulations, I don't remember what it's called, but there's a bill saying that, you know, phone systems have to be able to dial 911 without any other input, okay? Now, do I think that's a good regulation? I'm not here to say. Okay, I think you can make an argument that that's a very costly regulation that could have a pretty negative impact, especially on small, mid-sized businesses. Okay, but that's a regulation that exists, so you shouldn't be using PBX. Now, having said that, I don't know why you would ever install PBX in the past 20 years. Okay, so it's very difficult to maintain. It's very complicated, and you know, VoIP just does everything so much better. Okay, there's nothing that PBX does that VoIP can't do. Not a single thing. Well, I guess you can make an argument that PBX will allow analog transmission. Okay, I'll give you that one. Nothing else. Okay, nothing meaningful in terms of features. How about that? Does that make sense? So I think PBX, pretty outdated. But anyway, it's a wiring diagram. You can make an argument that a patch panel would be. I would consider a patch panel to be more along the lines of a physical network diagram. Yeah, I'm not going to split hairs with where exactly it would go. But in general, you know, a physical network diagram is going to be, you know, layout of your network. It's going to have, obviously, your core. It's going to have the border. It's going to have different layers associated with it, of course. It's going to have, you know, basically down to each and every device on your network. Logical network diagram, we talked about those. Asset management. Okay, like I was talking about with having an inventory. Okay, not only knowing what equipment you have, but knowing where it is. Okay, even a place like Fort Lewis has multiple network closets. Okay, and even in buildings, there's multiple network closets. So knowing what equipment is where, vital. Okay, because otherwise you can be rolling around like a chicken with your head cut off. Okay, trying to find a spare piece of equipment. It's not a good look, is it? All right, speaking of chickens and turkeys, I got a question for you all. Why is the turkey always the drummer? He's got built-in drumsticks, right? Okay. IP address utilization. Now, I would make an argument that part of this should be, you know, manually done. Part of it should be automatically done. So when you're talking about static IPs, should it be automatically documented or manually documented? Manually. Why? Yeah, so you want to know what server you assigned which IP, right? Or let's say you had some other device you assigned a static IP to. There's lots of reasons you may choose to assign static IP, but mostly it's going to go to servers and other network devices. Now, having said that, your DHCP devices, is it even possible to manually document them? Well, I would say if you have a very long DHCP lease and nothing better to do with your time, it's probably possible. Is that a good use of time? Not even close, okay? Just get it from whatever's assigning. You get it from your DHCP server. Does that make sense? No reason. Now, having said that, should you document somewhere what the ranges are that are applied to your DHCP server? Of course. Okay? You should document everything that makes sense to document. And lastly, you got vendor documentation. So that's going to be like you got a router from, say, Cisco. Somewhere you want to have copies of the documentation for it. Okay? It's not going to be a huge deal because you know, one router from Cisco and another router from Cisco, do they mostly have the same functions? Yeah. Okay. There might be some slight differences, maybe some slight differences in terms of specifications. But if they're running the latest firmware, are they going to do the mostly the same thing, if not the same exact thing? Yeah, of course. All right. So baseline, what performance do you expect? 4 major Performance components, obviously you got processors. This includes both CPUs, could include things like APUs, GPUs, whatever processors you have. Okay, memory, not just memory size, but also what? Speed, exactly. Okay, so, if you had a system running DDR5 with 8 gigabytes of memory, would you expect more or less performance than a system with, say, 12 gigabytes of DDR3? It's going to depend on the task, but in most cases, you would expect the faster memory to perform better, ceteris paribus, even though there's more of the slower memory. Okay? Now, it's also going to depend on what your swap would be. So let's say you were running a data set that were 6 gigabytes, and you had the option of doing on a system with 8 gigabytes of DDR5, or let's say 12 gigabytes of DDR3. Okay, so your swap is something like, and by swap, of course, I mean page file. Okay, so if it's a hard disk, what would probably be faster? The slower memory would probably be faster, right? Let's say you've got something like a modern NVMe M.2 SSD. Then it could be more of a toss-up. Okay, because most of the time you're going to be able to keep stuff in the memory, even in the 8 gigabyte system. General rule of thumb for databases and data sets, you want to have twice the amount of memory. So if you got a 10 gigabyte data set, based on that rule of thumb, how much memory should you have minimum? 20 gigabytes. Okay? Non-volatile storage. So, not just the capacity. In fact, the capacity doesn't really have a big impact on this, to be honest. Now, you don't want to be much more than, say, 85 to 90% of your capacity utilized, because then, certainly will slow down. I'm not getting into the SMR argument or anything like that, but when you're talking about non-volatile storage, think about the type of it. Okay, is it a hard drive? Is it a solid-state drive? What type of solid-state drive is it? You're talking about a micro SD card? That's going to be slow, There are no fast micro SD cards. Okay, not compared to other solid-state media, at least. Using SATA. Well, obviously, SATA is going to be slower than something like an NVMe M.2 drive, right? Okay. So, consider the speed. Also consider the capacity. But, look a little bit beyond those two things, okay? Think about the cache. Okay, you got a drive with a 32 megabyte cache in 2021. Is that going to be very fast, likely? No. Okay, you'd want to see a much bigger cache. Probably more like, I don't know, 128 megabytes, 256, something like that. Then lastly, a network adapter. Now, on an end user device, is that really going to be that big of a speed differentiator? Definitely not, especially not on a consumer network, okay? You got a home network, probably got a few devices, actively using the network. Network adapter's not going to have a huge impact. Now, let's talk about servers. Okay, so in server environments, you think the network adapter may have a bigger impact? Yeah, I think you can make that argument. But I would make an argument that what's more important than having a really good network adapter is having two decent network adapters, right? What does having two network adapters buy us on a server? Redundancy. Why is that important on a server? Exactly. And beyond that, if we're a big enough company, I'd say more than a couple hundred employees, okay, do we want to just have one ISP? No, we want to have at least two. Okay? So you may build in complete redundancy in your server environment, such that if one ISP goes down, okay, what do you still have? Same thing you do with power, okay? You have multiple circuits inside of your server room. You're going to have multiple ISPs as well, okay? So you have, let's say, a standard server on the back here. Maybe here's a power supply, and here's a power supply, okay? So one of these goes to one circuit, the other's going to a completely separate circuit. Okay, that way if a breaker trips, or if you lose power or something, it's powered by different stuff even maybe. I mean, you may see one is backed up with like a diesel, and you may see this one over here. I don't know, maybe it's backed up with something like solar or wind or some renewable stuff or whatever. Okay? That's going to allow you to have a lot more fault tolerance, right? Okay. Now, can you realistically get multiple power providers? Is it possible? Yeah, it's possible. What's the downside of it? Okay. Downside is most of the time with power especially, you got one power line, just a matter of who you're paying for the electricity. Okay. So, realistically, the difference here is a different circuit most of the time, and possibly a different backup power source. Okay. It wouldn't make sense to have these on the same diesel generator, would it? Okay. If they're on the same diesel generator, what's the point of even having two? All you're really doing is just saying if the breaker trips. Well, it's pretty unlikely to happen unless there's an electrical problem. So, having different, and you could have different diesel generators, okay? Whatever you want to do there is up to your company. But redundancy is probably more important than having a really great network adapter. Does that make sense? Okay. So processes. Okay, obviously, occasion, it's going to be important that you look through the logs. Okay, this is system logs, this is network log, whatever type of log. You have some process in place where you review them periodically, looking for maybe errors, looking for maybe abnormalities, okay? Looking for a lot of things that may indicate you need to investigate further. Okay, patch management. This is vital as well, okay? So in general, you don't just want to roll out a patch as soon as it releases. Because if you do that, quite possible that the patch has some problems. Maybe it breaks an existing system you're using. Maybe it overwrites stuff. Windows 10's had several like that. I think they were deleting people's documents folder with one of the Windows 10 updates if they're using a different drive other than C or something like that. I'll let you guys look it up and verify that. But the point is that patch management's important. Okay, so you have a dedicated testing environment that is basically somewhat of a mirror of your actual environment. Okay, and the purpose of that is to allow you to test the patches in an environment that's not going to have a substantial business impact should something go wrong. Okay, if you don't do that, you roll out a bad patch, you could lose all your information. That's possible. You could lose days of work. That's possible. You may have to reinstall everything. It's all possible. Okay, now is it likely for any of those one thing? No, it's not likely for any one of those, but when you have many potential problems that could go wrong, they all have some probability. That's cumulative probability, right? Okay? That's why patch management policy is important. Okay? And then lastly, you want to have the ability to roll back anything that may have gone out that shouldn't have. Okay, I think that goes without saying. If you roll out a bad update to, say, 20 access points, just roll it back. Okay? How do you do that? Well, obviously, backups are a big part of that. Having the ability and knowledge to be able to do so, it's all important to it. All right. Let's go through policies, procedures, and regulations. Okay? Boy, if this isn't the funnest part of this class, I don't know what is. Okay? So policies. Policies are basically what we should be doing as an organization. Okay? So we have a policy that says you must wear shoes in the building. Okay? Now, you have a procedure that says what happens if you don't follow the policy. Okay? It's how we're going to do it. How do we realistically make an employee come in to work wearing a pair of shoes? Okay, that's in your procedures. Okay? Now the good news is, just threaten to terminate them. Okay, it's not very difficult. Okay, is that blunt? Yeah, of course. But that's reality. Okay? Pretty much you can solve any problem in the workplace that way. Now, I'm obviously not an HR person. Okay, there's probably more polite ways to handle a lot of things. Whatever. Regulations. Okay? Regulations are like government policies that they mandate on everybody. Again, have your own opinion about them. I'm not here to say what I think of regulations. Okay, but it's basically, there's going to be penalties associated, or there can be penalties associated with not following regulations. It's up to you what regulations you want to follow, though. Okay, I would never tell you what you should or shouldn't do, unless I were your consultant, and then that's exactly what I would do. Okay, so safety. Thought this was kind of a funny part of the book. Okay, I'm going to summarize it with 3 bullet points here. Okay, don't electrocute yourself. Okay, you got high voltage stuff. What do? Leave it to someone else, right? Yeah. Okay. Don't overexert yourself. Don't lift more than about 50 pounds without, team lift or something like that. Okay, and then lastly, don't expose yourself to harmful chemicals. See that disinfectant right there? I'd be very disappointed if Ben chugged that, okay? That would be exposing himself to harmful chemicals. That would be very bad, okay? Luckily, Ben's not going to do that. Are you, Ben? Okay? Why are you not going to do it? Yeah, exactly. So you just follow the safety rule, okay? Let's see. So you in the back there, you going to stick a fork in an outlet? Why not? Yeah, you would. Okay? That'd be bad, wouldn't it? All right, let's see here. Who else can I pick on? Patrick. Are you going to go outside and lift your vehicle up to work on it? Okay? Maybe you're tougher than me. Okay? But you might be lifting too much, right? Okay? Follow these 3 rules. You'll probably not have too many workplace injuries. Could you add a bunch of other rules to it? Sure. Okay? Sometimes IT can be a little bit too much fun, right? So it wasn't me doing this, but I know someone who was doing some work, and they had a cart to put systems on. Okay, so the cart was empty, and there was a ramp. And you probably see where this is going, okay? So, person got on the cart, rode it like a skateboard, and guess what they did? They hit a wall, and they injured their leg. Okay? Now, was that fun? Yeah, it was fun. Okay? Should you do it? Okay? You shouldn't do stuff like that. Now, if you do it anyway, that's on you. Okay? But I'm suggesting against harming yourself. Does that make sense? Okay. So, it's also important that businesses have emergency procedures in place. One of the main ones of these is going to be the business continuity plan. Okay, so business continuity plan basically just states, how do we continue operations in the event of some sort of disaster? Maybe a flood, fire, earthquake, maybe even like a hostage situation, whatever. Could be man-made, disaster, whatever. Okay, the main component of this is going to be redundancy. Okay, so, we have multiple power circuits. We have multiple ISPs. We have multiple of everything that's critical. Okay? You're not relying on a single point of failure. Have 2 or more points of failure. It's a whole lot less likely to have 2 things fail at once. Not impossible, but it's less likely. Okay? And then also consider, how do you notify people? Let's face it, our cell phone's infallible. Okay, during Hurricane Katrina, were people able to use cell phones if they were at the New Orleans area? Well, they couldn't really communicate with them. They could certainly use them for their basic functionality built in. But in terms of communicating with cell towers, you can't solely rely on that. Now, having said that, what else do we have? What about email? Now, if someone doesn't have cell service, do they likely have internet service? Pretty unlikely. But it's possible they may. Okay? What about the mail? The mail claims to run in, what is their motto again? Like rain, sleet, snow, hail, something like that. It'll get the mail, will get to you, something. I don't remember what their motto is, but they claim that they will always get letters to you. Now, Who believes that? Okay, does anyone believe that? You got 12 feet of surge from a flood. Do you think your mail truck's going to be coming down the road? Well, it might be coming down the road, but not on purpose. I shouldn't joke about that. Anyway, you get the idea. Have multiple ways your emergency alert will communicate. Here's a few tips from the book about designing buildings. Okay, so you got a big commercial building, and you're going to have the possibility of a fire. Okay, now, the good news is that we've come a long way when it comes to fire safety. Okay, so can we potentially isolate a fire to a specific room? Is that possible? Sure. Okay. So, suggestion is all walls inside of an enterprise building should have at least a 2-hour fire rating. Now, I don't know what building code is. I think it varies by not only state, but even by area in a lot of cases. But I do know that in some areas you're required to have a smoke test. Okay, so the smoke test is, see drop ceilings like this? Okay, what they do is they get brackets that sort of push down a little bit on the ceiling tiles. Okay, it makes it very difficult to remove them. Okay, and the purpose of that is so that if there were smoke, it wouldn't be able to travel freely throughout the building. Okay, because what kills more than fire? Okay, the smoke from the fire kills more than fire, right? Yeah. So you want to avoid death. Okay, one of the ways to do that is to have good fire and smoke ratings. Okay, doors should resist forcible entry. I think that's a good thing to think about. But the problem is that fire codes prevent that in a lot of cases. Okay? So you've also probably seen videos where people get like a coat hanger and a commercial door, and they just kind of bend it and they just push the push bar, and they're in, right? Okay, fire code makes you have stuff like that. Now, you can have your own opinion about fire code. I'm not really here to debate it, okay? The reality is that you may have that situation. How could you avoid that and be in compliance with fire code? Well, you could have multiple locks, right? So maybe you have not only the standard push bar, but you also have, say, a magnetic lock that's push to exit. Now, could you theoretically somehow still manage to push the push to exit button? Yeah, but you're making it a lot more difficult than just slipping a coat hanger between a door, right? So I think this one's more of a nice to have. I don't think it's necessarily feasible in every case. All right, you got to document where your fire system is, or fire suppression system, I mean, and make sure you know what type. So for instance, you got a data center. Should you have a water-based fire suppression system? Why or why not? What do you think, Patrick? Well, electricity, but what about the data itself? Be toast, okay? Do you want to have like maybe a halon-based solution or something? No. What's the downside of that? It might, but it's dangerous to humans is the point that I was thinking of, okay? So in general, you have a data center, you have between like 10 to 30 seconds to get out, okay, in the event of, so if you start to hear alarms and you start to see flashing lights, get out, figure it out later, because it doesn't take very long to inhale that stuff to die, okay? Like I said, I don't mean to be blunt talking about death, but I'd rather talk about it than have a tragedy, okay? Use raised flooring inside of data centers. Okay, so this is going to help with floods, certainly, but it's also going to make it a lot easier to work in a data center if you have raised flooring. Okay, so if you think about it, you have a raised flooring, you can put your cabling underneath there, right? Who would rather raise up a floor and move cabling versus climb a ladder and get in a drop ceiling? Okay, you'd probably prefer to not climb a ladder and get in a drop ceiling. It's really up to you, though. Okay, so separate AC units. Again, this goes back to having different fire suppression systems. So for most of the building, water base is probably perfectly adequate. But for a server room of some sort, or data center, whatever you want to call it, it's certainly not adequate. Okay, so the separate AC system is going to really be helpful in preventing smoke from entering or leaving, and also preventing dangerous gases from entering or leaving. Could you make an argument against having ducted AC or ducted HVAC? Could you make an argument against it? I think you could. Okay, maybe you want to use a ductless system. Maybe you want to use whatever. You got a lot of options. Okay. Lastly, we talked about backup power sources already. All right. So we talked about VLAN and subnetting. We didn't go into a whole lot of detail on what you would VLAN and subnet. So I think the most obvious thing is VLAN and subnet your testing environment. Okay. There's no telling what you're going to be using it for, right? You can't assure anyone what a testing environment will or will not be used for. Therefore, it makes sense to VLAN it off from your network, right? So if you do something crazy in it, you're not harming your actual network. Okay? Obviously, you'd also want to segment your guest network. Okay? So imagine you had a nefarious guest come on your business property, and they were able to get on your standard network just by using a guest network. Okay, would that be a bad decision on the network admin's part? Be an awful decision. Okay? VLAN and subnetting are quite simple, are they not? Relatively simple. Okay, you got legacy systems not getting modern patches. You know, you may even not just want to VLAN and subnet. You may even consider air gapping them. Okay, that's really going to depend on what your organization wants to do. Okay, so security cameras. Now, there's a couple of reasons we want to VLAN and subnet these. Okay, number one, let's say we're a cheap company. We're purchasing Chinese cameras. Okay, so for instance, purchasing like Hikvision. Okay, have there been documented instances of those security cameras sending packets to, say, China? Has that happened? Yeah, it has. Okay, that's why those brands are banned inside of not only federal buildings, but also federal contractor buildings. Okay? So, for instance, let's say you're Lockheed Martin. Are you going to cheap out on your cameras? No. For one thing, you can't. For another thing, it wouldn't make sense to. Okay? Let's say you're a smaller company. You're not doing government contract. Nothing hypersensitive. Okay? You VLAN and subnet, you can control what leaves the cameras. Okay? So you may decide to not give them any outbound internet access, for instance. Is that possible? Yeah, it's possible. Okay? Another reason to VLAN and subnet. Okay? So do you want that to negatively impact your main network's performance? Let's face it. You have a 1080p camera. Okay? That could potentially use, you know, if it's got a high enough bit rate, it could use upwards of 10 megabits a second just for one camera. That's possible. I'm not saying it will, but I'm saying it's possible. Okay? Start getting into, say, 5 megapixel, 8 megapixel, it gets even more severe, right? 1440p, 4K. So if you have that segmented, you can control that a lot easier. And then there's also the obvious problem. You know, do you want just any old person to be able to potentially connect to your cameras? Hopefully you don't. Okay, that kind of defeats the purpose of a camera, does it not? All right. VoIP. Again, the main reason to segment this is to make it easy to do quality of service. Okay, so if you have a VoIP network, only VoIP devices are on it, it's going to be quite simple to apply whatever policies you want to it. Now, VoIP obviously not going to use a ton of bandwidth. Okay? You're talking less than a megabit a second, way less than a megabit a second. A lot of times just a couple kilobits a second. Okay? And then, of course, you have something like supervisory control and data acquisition industrial control systems. Okay? So that's like if you had a big plant. You know, maybe it's a water treatment plant. Maybe it's a factory. Maybe it's an oil production facility. Whatever it is. Okay, it's got some sort of industrial control system on it. Okay, you don't want just anyone to be able to get on the network and see that system. Okay, you want to have it separated off because that's like your main, your primary business activity, sure, but it doesn't even just affect your organization. Think about the Keystone Pipeline, So if the Keystone Pipeline has an attack on it, what happens to gas availability? Does it increase or decrease? Okay, it decreases, right? So is that a problem? Not just for Keystone. It's a problem for everyone, isn't it? Okay? Truck drivers can't fill up. Okay, well, if truck drivers can't fill up, what does that mean about grocery stores? It means they can't stock, right? Okay, if grocery stores can't stock, what does that mean? What does it mean? Yeah, you're not going to be able to buy food. Okay? That's why you should always make sure you're VLANing and subnetting your network. Now, is that infallible? Obviously not. It's not the only measure you would take to secure a system. But it's certainly an important measure. Okay. So why we want to optimize our network? Well, I think the main reason is obvious. Okay, if we optimize our network, we're going to have performance is going to be better overall. It's not going to be better for everyone. So last class, I think I was using the example about, if I'm downloading a Linux ISO, do I want to be able to go full speed ahead, or should I go just a little bit slower? Okay, to allow, say, a VoIP call to go uninterrupted. And what conclusion do we come to? I should probably go a little bit slower. Okay, that's right. Okay, so thinking about that, it's going to allow us to have better performance for everyone. Not necessarily completely better for everyone. Am I going to be missing those handful of kilobits a second? Not in reality. But as a joke, I would. Okay? But it's really about protecting stuff that's going to be sensitive to latency. Downloads aren't sensitive to latency, are they? Most of the time. Okay? So, hypothetically, if you're playing an online game, okay, it's probably using UDP, right? So, imagine there was a big download going across the network at that time. And you didn't have QoS. Okay? What's prioritized, who knows? But you're probably going to be not having 100% of your packets delivered on time. Maybe you have some jitter. Maybe you have some packet loss, whatever. Okay? So anything that's going to be needing real-time communication is probably going to cross UDP, right? Not 100% of the time, but for the most part, UDP is going to be preferred here. So could you, for a simple QoS rule, could you just go through and say the UDP protocol is prioritized? Could you do that? Yeah, you could. Would that be an easy way to handle things? Yeah, of course. Okay, so really the whole purpose of quality of service is to provide better overall service for everyone. It's going to reduce delay in most cases. Not every case. Like I say, big downloads, that's what's going to be most harmed by quality of service. But it's for a good reason. Okay? Drop packets, certainly that's going to be a big problem for UDP. Okay? Errors. Again, it's going to reduce the likelihood of errors. Jitter and out-of-order delivery. Okay? We can address all of these. We don't have to, but I'm saying we can. Okay? So we can use stuff like traffic shaping as well. Okay? So traffic shaping is whenever we take the packets and based on whatever criteria we set, we delay certain packets. So let's say that we had, I don't know, a big download. Maybe someone's downloading, for whatever reason, they're downloading like a terabyte of Linux ISOs. Okay? So you're downloading that, and based on the criteria you set, you may choose to throttle that download to allow other traffic to go unimpeded. Okay? Or at least less impeded. I wouldn't say unimpeded. And the cool thing about this is just like quality of service, you can set literally anything you want. There's no limitations here. Hypothetically, could you delay VoIP packets? You could. Okay? Does that make a lot of sense? No, it doesn't, but it's funny to think about, isn't it? Okay? You could purposely have people's phone calls be garbled. Okay, is that kind of cool? I think it's kind of cool. Is it useful? Well, not in that particular context, but the broader scope is throttling is pretty useful. Okay, so here's some assorted operation or optimizations. We'll go through these quickly. Most of these we've covered already anyway. Okay, load balancing. Let's say at basic level you got 2 servers. Okay, maybe one request goes to one request goes to another. It's even possible to have the requests be split between servers with load balancing. It's not just servers. Obviously, this could be stuff like network traffic, Have 2 routers. Okay, it's certainly possible. High availability. It's obviously making sure that systems have minimal downtime. Okay, so we get there mostly with redundancy, but also things like competency. Caching engines. You got a file that's downloaded frequently. You have a server. It's going to cache it. Okay, great example of something like this is something like a WSUS server. Okay, so what's a WSUS server? Okay, it's a Windows Update server, right? So you host it locally. That way you're not having to download the updates repeatedly from Microsoft servers. It's good for Microsoft, it's good for your company. Fault tolerance. Okay, so you're not just having one single path that something could go, you're having multiple redundant paths. Archives and backup. Obviously, you'd want to make sure that you're backing up anything that is important to your organization. Okay? So let's say you have an accounting database. Okay, you should be backing that database up regularly, right? Obviously. Okay, cloud computing. Obviously, cloud computing is going to be using external hosts to do basic computing tasks. And lastly, cable and power management. I don't really see this as a huge optimization, but the book mentioned it, so I'll mention it as well. This could be more of a beneficial thing to reduce the cost of maintaining your whatever system you're using. So for instance, imagine you're an internet service provider. Okay, so internet service providers, they don't just go to homes, they go to, big enterprise buildings, but they also go to stuff like apartment buildings. Okay? So when they go to an apartment building, what do they most likely have to do? Do they most likely have to get out a tone generator and tone to find out which cable is which? They most likely have to do that every time. Yeah, they probably do. Why? Okay, that stuff's notorious for being poorly labeled, right? So, if you had good cable management everywhere, you wouldn't have to do that as often. Okay, is that going to be a huge time saver? Well, it's going to be pretty big, but you got to remember, the person who would be doing that sort of work probably pretty poorly paid. Just being blunt, okay? So, you're paying, basically you're saving 20 bucks an hour when you could be saving, a couple hundred an hour, whatever. You got to think about those things as a business, okay? So just to wrap things up, we talked about documentation, talked about network monitoring, and we talked about network optimization. Any questions? All right, so Friday begins the lab days. Look on the schedule for that. Apart from that, have a great weekend. If I don't see you Friday,